Hi friends, today I'm going to explain about AUTOSAR Basics Part 2. Already I posted the AUTOSAR Basics Part 1 video. If anyone didn't see still, you just go and watch that video. This is AUTOSAR Basic Part 2. Here you can see this AUTOSAR layer model. I will show. This is the AUTOSAR layer model. So here we have application layer, runtime environment, service layer, ECU abstraction layer, microcontroller abstraction layer, microcontroller, then complex drivers. So from this only I'm going to explain about what and all things. First one is microcontroller abstraction layer. So the microcontroller abstraction layer is the lowest software layer of the basic software. The microcontroller abstraction layer, nothing but MCAL, it comes under basic software. Microcontroller abstraction layer, ECU abstraction layer, and service layer, and complex drivers are comes under BSW, that is basic software part only. You just see here, I will show you in this here. See this service layer, this all things below runtime environment, this all is comes under basic software. So already I told that it is the lowest layer, and it contains the microcontroller abstraction layer contains internal drivers which are software modules with direct access to the microcontroller and internal peripherals. So next one is ECU abstraction layer. Sorry, in CAN stack, sorry, in microcontroller abstraction layer, in CAN stack, CAN module is present in this layer. In microcontroller abstraction layer only, the CAN module is present. In this microcontroller abstraction layer, some of the modules are included, that are microcontroller drivers, memory drivers, crypto drivers, wireless communication drivers, communication drivers. In that communication driver only, we have CAN module. After that, you have IO drivers. Next one is ECU abstraction layer. So ECU abstraction layer interfaces the driver of the microcontroller abstraction layer. It also contains drivers for external devices. Here the CAN IF module is present in this layer. In ECU abstraction layer, the CAN IF module is present. In this ECU abstraction layer, some of the modules are onboard device abstraction, memory hardware abstraction, crypto hardware abstraction, wireless communication hardware abstraction, communication hardware abstraction, and IO hardware abstraction. You just see the ECU abstraction layer offers uniform access to all features of an ECU like communication, memory, or IO, input and output, no matter if these features are part of the microcontroller or realized by peripheral components. The drivers for such external peripheral components reside in this layer only. Okay. So next one is service layer. It is the major part of the BSW, and it is the highest layer of the BSW, that is basic software. It includes operating system functionality, vehicle network communication and management services, memory services, diagnostics, ECU state management, and mode management. Already I have put one video related to diagnostics, diagnostic event manager DEM. You just go through that video also. I will explain everything DEM DCM concepts in my upcoming videos. So here also we have some of the modules that are system services, memory services, crypto services, offboard communication services, and communication services. Here we have COM, CAN NM, that is CAN network management, and CAN SM. All these modules comes under this service layer. See, this layer provides various type of background services such as vehicle network communication and management service, everything. So mode management, logical and temporal program flow monitoring. The operating system, already I mentioned that O is also the part of this layer. Then RTE. So the RTE integrates the application layer with the BSW. It implements the data exchange and controls the integration between the application software component and the basic software. Here you can see that here you have application software, and here you have this basic software. So with this help of RTE only, you can able to send and receive some of the data. That's the thing, data exchange and control the integration between the application software and the basic software. This is the main use of RTE. So what is RTE? Runtime environment. Actually, the application software cannot directly call API present in the basic software or any other. So the application software here, it cannot directly call any of the API present in the BSW software or else complex drivers. Okay, here. So there is something called ports in the runtime environment, RTE. These ports will be present in the RTE, I told. So if one application software is need to communicate with any of the basic software, so it has to link the ports. It has to link the ports between two applications first. RTE links these ports and communicate with as it is possible. So next one is AUTOSAR interfaces. AUTOSAR interfaces are used in defining the ports. Already I mentioned P port and R port of software components or BSW modules. Through these ports, software components and BSW modules, that is basic software modules, can communicate with each other, send or receive informations or invoke services. Here we have client server interface and sender receiver interface. I will explain this concept in my upcoming videos. You just try to know these kind of things first. So AUTOSAR makes it possible to implement this communication between software component and or the BSW either locally or via a network. First one is the AUTOSAR interface. Is a generic interface which is derived from the ports of a software component. AUTOSAR interfaces are provided by the RTE and serve as interface between software component or between a SWC and a ECU firmware, that is input output of hardware and complex drivers. This is AUTOSAR interface. So via these interfaces, a software component, like example like read an input value or write an output value. So next one is the standardized AUTOSAR interface. It is a particular AUTOSAR interface which is already predefined by the AUTOSAR standard. So it is normally defined by the AUTOSAR standard. Such interfaces are used by the software component to access the AUTOSAR services. I told now we have a number of services in the service layer. So with the help of this, all the services are accessed by the AUTOSAR, which are provided by the BSW modules of the service layer like an EC. So here they mention that BSW modules of the service layer like ECU manager, like what are the service layers are communication services, memory services, system services, and diagnostic services. In this communication services only, what the communication services nothing but it have all protocol software modules. Already I mentioned that module is nothing but, yeah, yes, source file and header file. So the communication services we have CAN network management, that is CAN NM, CAN state manager, CAN TP transport layer, COM, Ethernet, FlexRay, LIN networks, PDU, XCP, everything here. Diagnostic communication manager, that is DCM. DCM is nothing but UDS, Unified Diagnostic Services. And the second thing is memory services. In memory services, we have NVRAM, that is non-volatile memory. And in service layer, we have system services, that is COM manager, BSW mode manager, crypto services manager, watchdog timer, everything, watchdog manager, everything is here only. Final one is diagnostic services. Diagnostic is having diagnostic event manager, DEM, function inhibition manager, FIM, development error tracer, that is DET, diagnostic log and trace, that is DLT. And the third one is standardized interface, is an interface which is predefined by the AUTOSAR standard as API in C language. It is used between BSW module within an ECU, between RTE and the operating system, or between RTE and the communication layer. I will explain all these things in my upcoming videos. This is a basic thing. You just go through all those things. I will explain in everything in a clear cut, but you should study all these things. Next one is AUTOSAR basic software module. So AUTOSAR has defined a set of BSW modules. They are responsible for different tasks. That is operating system, access to non-volatile memory (NVM), communication via CAN, LIN, FlexRay, and Ethernet. So people have different experience in communication. So I work for CAN, and I'm working as a BSW basic software, AUTOSAR basic software. So handling the diagnostics. Already I told DCM and DEM and all comes in this handling the diagnostics, and access to IO, input and output ports, and system services like ECU state management. So in addition, we have complex device drivers also integrated in AUTOSAR ECU. See, this diagram belongs to BSW modules. Here we have DCM, Diagnostic Communication Manager, then NVRAM Manager, and these are system services. So this full belongs to, this belongs to basic software module. In this also we have complex drivers, microcontroller, then MCAL microcontroller abstraction layer, ECU abstraction layer, runtime environment, and application layer. See, we have CAN trans receiver drivers. So then we have CAN transport, CAN TP, PDU router. These things are all PDU, CAN TP, then CAN trans, everything I will explain in my upcoming videos. See, this diagram is related to AUTOSAR basic software system services. We have operating service and system, memory services, COM services, IO hardware abstraction. Then you just see Here we have a watchdog manager, diagnostic event manager, that is DEM. I uploaded one video related to DEM. I'm working on DEM, so I will clearly explain what and all things. You just uh, go through DEM concepts in that video. Then function inhibition manager, then comp manager, then ECU state manager, AUTOSAR OS and everything. See, diagnostic log and a trace. These all things are related to system services. See, I told these things are in the system services, that ECU state manager. The ECU state manager performs the initialization and the deinitialization of all basic software modules, including the RT and the operating system. The module controls the operating system of the ECU, like sleep, start, wake up. Main thing is wake up and shutdown of the ECU. You should know about ECU statement manager and run based on the system events. The actually the can enum. So next one is communication manager. This module controls the statement of all communication channels connected to the ECU. So, and provides a bus independent interface to the software and thereby their application for requesting external communication. Next one is function inhibition manager. So these things, function inhibition manager, diagnostic event manager, these and all comes under related to diagnostics. So this module controls functionalities of software components based on the conditions such as fault, signal quality, ECU. Suppose, for example, any ECU is in any fault state, then these kind of things, this diagnostics or else this function manager will occur. I will explain these concepts in my upcoming videos. So, and vehicle states, diagnostic tester commands, and etc. So then you have diagnostic event manager. This module implements error memory as per manufacturer specific documentation. A standardized interface for diagnostic monitors allow for uniform cross manufacturer developments of software components. The DEM module is responsible for administrating the diagnostic trouble code status, the error environment data for storing the data in NVRAM. Already I told DEM is nothing but it will log if any error occurs, the DEM will log. If something occurred in the core, I mean if something is occurred in the ECU, is occurred in the ECU, the DEM will log. It will give the indication like some problem is occurred, the ECU is in false state, like that kind of information you will get from the diagnostic event manager via diagnostic trouble code. Then finally we have MCAL, microcontroller abstraction layer. So here we have this CAN driver, LIN driver, FlexRay driver, SPI handler, Ethernet driver, EE driver, EEPROM, watchdog manager, every drivers, MCU drivers, every driver related things, everything will be present in this area. So you just need to know these kind of things. CAN driver, because some people used to work AUTOSAR via CAN and some people or maybe like to use FlexRay or LIN, Ethernet, anything is okay. The every driver here, see, the CAN driver provides services for using the CAN controller. So you have to initialize here only for sending and receiving messages and for switching the controller states. FlexRay, the FlexRay driver is used to abstract hardware related difference between different FlexRay communication controllers. All the necessary properties of the communication controller pair the FlexRay protocol specifications. Everything is based on the specifications, protocol specification are encapsulated in this module and can be reached via its uniform interface. Next one is LIN. The LIN driver provides services for initiating frame transmission, that is header response, sleep mode and wake up, as well as receiving response, checking the momentary state and validating wake up events. Next one is SPI handler or driver. This SPI provides an option for exchanging data across the SPI interface. It is primarily used for external connections of EEPROM and Watchdog. So mostly we will use this SPI driver in the external connections of EEPROM, so electrically erasable and Watchdog. Next one is Ethernet driver. The Ethernet driver provides an option for data exchange over Ethernet interface. With the Ethernet interfacing available in, it is possible to develop very powerful gateway with the most communication and thereby utilize the advantages of AUTOSAR architecture. So here the final thing is multi-core. You just see as the demand for computing power is rapidly increasing in the automotive domain, OEM and tier 1 suppliers are gradually introducing multi-core ECUs in their electronic architecture. Additionally, these multi-core ECUs offer new features such as higher level of parallelism, which is a respect of the safety requirements such as ISO C26262, nothing but which is related to UDS, DEM and DCM, and the implementation of other more complex automotive use cases. The main use cases for multi-core ECUs are decreasing complexity of architecture, dealing with resource demanding applications, improving the safety, dedicated use of force cores. So AUTOSAR 4.0 has introduced support for multi-core embedded real-time operating system. So new concepts are here. I will explain this multi-core concept in the upcoming classes. You can see this multi-core program. This is a single ECU but with multi-core. See here you have core 0 and core 1, application RTE, and the core 0 have these kind of things, that the COM services, memory services, and MCU drivers, memory drivers, IO, complex drivers and everything. And the core one we have complex drivers and have some system services, that is ECU, AUTOSAR, OS and everything. So we can split and we can write codings, because here we are not going to write that much code based on BSW. If you are willing to work for MCAL, then you have to write manual coding. Other than that, if you want to work for basic software, then mostly you have to configure the things. And the thing is, I think you have some other questions, or else if you have any questions, you just uh, comment, put comment. I will explain you as soon as possible. And the thing is, you are not going to work the entire AUTOSAR. Nobody is going to work on entire AUTOSAR. Whether you are going to work for RTE basic software modules, or else MCAL, or else complex drivers. So the thing is, if you have any doubts related to anything, you just put comment. I will explain whatever things you have doubt. So the thing is, try to study what and all things I just explained here, because I'm just giving the data. Mostly they are asked in the interviews. You just study all those things which I give now. These and all things you will. These and all the questions you will get. You will. Uh, in the interview they will ask you. So thank you so much, and subscribe my channel, and if you have any doubts, please comment